Awesome. Glad to hear it. So, my name's Jake Anderson. I work for Byte here in Lehigh. Uh, they're they're a little startup that just got bought out by a massive company. We sell dental aligners for like half the price of Invisalign, 100% remote. It's pretty cool to work for. So today we're going to be talking about uh, how Snowflake works, separation of compute and storage, and how do you optimize that compute for both cost and performance. So a couple things before we get started. Snowflake is awesome. I love Snowflake, except its nomenclature sucks. It's pretty bad. So I'm going to be talking a lot about a warehouse today. And if you're not, in Snowflake all day, every day, you're going to hear warehouse and probably think like a data warehouse. But that's not what it is. In the Snowflake ecosystem, a warehouse means your compute resources. And so just in your mind, you're probably right that a warehouse is where you store data, modeled data for analytics. Snowflake disagrees a little bit. So before we dive into the compute resource component of it, that virtual warehouse, it's important to know and understand how micropartitions work, because this architecture is what fuels everything that makes Snowflake unique, or at least most things. So in case you don't know, when you do like your select star or something like that, and you get a table back and it looks like a CSV, that's not how it's stored on disk. And so this is straight from the Snowflake docs of how they do it. They separate this out into micro partitions. And so in Snowflake, these are teeny tiny. Think like 16 meg each max compressed, 50 meg to 100 meg uncompressed. And so really small, everything is indexed. So when if you look on screen, when I say, hey, I want this row here, it's super good at at pinpointing exactly where to scan to pull that row in. Each micro partition has metadata stored about it, about these are the range of dates, this is what's in here. And so it makes Snowflake out of the box really fast to be able to find those little micro partitions. It's so good at only using columns that are used. Its compiler is lazy, in fact. So when we look at this query, if I were to just run rows 2, 3, and 4, I would get a divide by 0 error, right? I can't divide 1 by 0. That's a no-no. But if I go ahead and execute this query right here, where I'm not including this column, oh no, then it runs just fine, because the compiler's that smart to say, hey, look, I'm not just looking at the columns that are used in these tables and if they're referenced, I'm looking at the columns that are used in the final output. So really cool stuff. If you take the time to go look at this SO article, they've got some cool stuff as well, like how you can use this for embedded unit testing, or if you want things to fail for whatever reason. It's pretty cool stuff. I really enjoyed that read. So as we take this micro partition even further, we kind of want to think about, so if I've got thousands or even millions of these teeny tiny micro partitions, these teeny tiny files, what happens if I do an insert or an update? Well, what happens is the micro partition is not instantly deleted. It's then invalidated, and a new micro partition is created. Every micro partition is immutable. That means, once it's written, it's written. We never update micro partitions. We make new ones, and we transfer over whatever little pieces we need. So this makes it so that so some of the unique things about Snowflake, this is where the magic happens, right? So one of the things that the Snowflake marketing material will tout, and which is really cool, is time travel. So let's say, uh, 3 days ago, your accountants come in to you and say, "Oh no, something was wrong with the books. We don't know what it is. What was the data like 3 days ago?" Time travel allows you to do that because what's happening, it's you just put it in the where clause. You say where data at, you can put your timestamp, or where data before such and such query ID. And so that makes it really cool because what's happening is Snowflake is saying, oh, okay, for that table at such and such date, which micro partitions was it pointing at? And that's how you're able to go back in time, if it were. This also allows you to do other things like undrop the failsafe feature, because there's all these micro partitions you can just reference. Clones are really cool as well. If you've ever struggled with, I know there's a lot of companies that have struggled in the past with, I want to make sure that dev and stage match prod. The way you do that in a more traditional database, it can be painful. A lot of people don't do it very well. But in Snowflake, when I clone from prod to stage or prod to dev, it's lightning fast because the only thing that's happening is I'm saying, hey, Snowflake, I want a new set of pointers at this set of micro partitions. And now there's just pointers. I'm not physically moving data on disk or anything like that. So really slick. Lots of people use it. It's one of my favorite features. When I was demoing it, when I was trying to get Snowflake at a company I worked for, I blew somebody's mind as like, hey, here's 1.5 billion row table. Let's put it in stage. 1.5 seconds later, it's there. So really, really cool stuff.
Hey, Jake.
Yeah.
Question came in on chat. Do you have any examples of embedded unit testing that you had mentioned before?
So I do not. I don't personally use it. I use DBT and DBT tests for that.
Okay.
But this article right here that I have referenced does have some examples of that.
Okay.
Let me post that in the chat so you don't have to like screenshot it and type it out.
Well, and for sure afterwards too, we can probably share these slides in a comment on Meetup. Yeah.
Definitely.
Okay, thanks.
So as we think about these micro partitions, you start thinking about these as saying like, hey, wait, if these are just like these teeny tiny files that I just need to start scanning, well, now this is where the clusters come into play. So I'm able to say, hey, I'm going to have virtual warehouse A, and that's going to scan these partitions, and that can be completely independent of B and of C. That everybody's just able to, kind of do their own thing, not worry about what other people are doing, things like that. And so it makes it really handy. And it starts to say, well, if A and B are completely separated from each other, then maybe, just maybe, A doesn't have to be the same size as B. And maybe, just maybe, I can start isolating workloads and I can start customizing how I do my Snowflake deployment based on how people are actually going to use it. And it makes it so you can start being really targeted with, what you do, how you pull it in, and you can do some pretty cool stuff. So I've done a lot of talk about micro partitions and what they're used for and how they work. Can we, I just want to pause and see what questions there are before we start getting into how to configure these things and what options exist.
I haven't seen any additional ones in the chat, but feel free to, if anybody wants to unmute and ask one, go right ahead.
Can I ask about the time travel?
You bet.
Have you found a good way to keep costs down, and how long do you make your time travel go out? Do you go out more than a few days, or?
I find that 7 days is usually, if I can't catch it in 7 days, I probably wouldn't have caught it anyways.
Do you find it's pretty expensive though?
It can be. So it depends on the churn. of how much churn you're getting in your tables. Because you think about how a partition is immutable. And when you create a new one, you're not just having a partition of what was there before, you have everything in there. And so your storage can get pretty big pretty fast if things are changing a lot in those tables. So the way that you get around that is you do transient tables, and you can just schedule them once, you start scheduling backups. Has been my experience of how to keep costs down.
Thank you.
Can I ask a question? What about the undrop feature, like for GDPR and compliance and stuff?
Gotcha. Oh,
Question.
sure. So like right to be forgotten, things like that.
Yeah.
So like if you get a forget me request, how do you make sure that it's really gone forever?
Yeah.
Oh, so like undrop, time travel, and failsafe, they all have a limited time frame. Time travel is whatever you configure it. Undrop, if I recall correctly, it stays in memory for 24 hours before that's expired. So this stuff will drop off automatically.
Great. Thank you.
Other questions, or are we good to start talking about configuration? Silence is agreement. So as we start so we've talked about how if these warehouses, these compute clusters, as I like to call them, are scanning through independently of each other, and they're just scanning a collection of teeny tiny files. Well, then let's start talking about how we can configure them. The options that you'll spend most of your time thinking about is the maximum clusters and the size of your warehouse. So you have scaling policy and auto suspend. Most of the time for auto suspend, people just set it to 1 minute or something really small. For most data warehousing loads, you don't need it constantly on, right? Maybe if you're doing some near real-time streaming, maybe you're like Kafka's your jam, you might want to keep that. But my experience is that most people just set it for a minute and let it go. So let's talk about size and number of clusters. So the best analogy I ever heard for this, of wrapping my head around it, is thinking of this as kind of like a highway. When you say the size of my warehouse is the speed limit of how fast I'm going to let cars go through, how fast I'm going to let Snowflake churn through those micro partitions. And quantity of clusters is kind of like the number of lanes. And so with Snowflake, and this is where it gets to be a little bit of a balancing act. There's a great quote from Severus Snape that I really like, where he says it's something to the effect of like, it's the exact art and subtle science of potion making. It can be like that a little bit with these clusters. So I'll get to kind of how you manage it, but there's a little bit of like, do I do a little this, little that? And here's some examples of why. So let's say that I just take a cluster and I'm like, you know what, I want this thing to go fast. So I'm gonna say speed limit 65. But if we look at this picture, if I have too many cars on the road, then that's not really gonna work for me, right? Because even though the speed limit's 65, even though I-15 speed limit's 70, at 4, 5, and 6 in the afternoon, you're not going 70 because there's too much congestion, too much concurrency to allow that. But maybe we say, hey, I'm just gonna create a bunch of lanes. I'm gonna let this warehouse scale up. So now I have more concurrency. But if you set the speed limit too small, if you set the size too small, you don't really optimize it. You don't really take advantage of it. And so now you've left some money on the table, as it were. or some compute power on the table. So maybe you get to the point where you're like, all right, I'm just going to do max everything. I'm going to say speed limit 80. I'm going to have 10 lanes of traffic. Things are just going to fly, and your database will fly. It will also cost you an arm and a leg. So if you take the highway advantage, imagine I-80 through the middle of nowhere in Wyoming. You could make that a 10-lane highway. You could set the speed limit to 100, and cars will go flying, but it's going to be pretty pricey. So as you're trying to get it just right, that's the way to think about it. So as we talk warehouse size considerations, these don't dynamically scale. You set it, and you can always run a command to add it, bump it up, bump it down. If you can even embed it in your Python or whatever you're using for your ETL. You can be very dynamic, but Snowflake won't automatically say, hey, this is a big query, I'm gonna throw resources at it. We call this vertical scaling, and it behaves linearly. A small is 2x faster than an extra small. A medium is 2x faster than a small, and it has that approach. Now you also see that same curve in the costs as well. So an extra small, for example, is one credit per hour. A small, 2 credits per hour. Medium, 4, so on and so forth. And there's a good relationship to where you'll get double the performance. If we think back to that micro partitioning example, or as we think of how fast can I scan thousands or millions of tiny files, a bigger warehouse, more compute power, more power, as Tim the Toolman Taylor would say all those years ago, that'll get through faster until it doesn't. So you're at a certain point, you start getting diminishing returns. And so if you say 5XL for everything, and then there isn't enough work, or I want 5XL on a query that takes an extra small 5 minutes, you lose out on those advantages. And so if you're not careful, you're going to be doing, you'll be paying more for double the power, but not getting double the performance. One of the things that we changed recently at my job is we moved a medium to a small, and we found that for our whole data warehouse nightly job, and we found that it took, normally it runs in half an hour on a medium, or excuse me, normally 20 minutes on a medium, and then it took 27 minutes on a small. And that's because we have a lot of small queries where, 30 seconds, maybe it's 30 seconds here, 90 seconds there. You don't get as big of those drops. So, but let's talk about horizontal scaling. When we talk about how many clusters. So each cluster has a max concurrency of 8. And you can decide how many to stack next to each other. So a good use case for this is, let's say you have Tableau, Power BI, Looker, whatever, and you have a bunch of users using this all at once. If you're doing BI right, you should have more than eight people at a time, right? So it usually makes sense to tell Snowflake, hey, if you detect a lot of people, a lot of concurrency, go ahead and get wide, spin up to a certain point. That's a good advantage. It does it automatically, and so you don't configure anything. Snowflake just knows. It's not available on the standard edition. One company I know, they really wanted to take advantage of this, but they weren't on the standard, and so they were trying to they were on the standards, excuse me. They're trying to just kind of do like a poor man's version, and it's really hard to do this without leveraging Snowflake's auto scale feature. And it won't scale out forever. You set a limit, right? the last thing you want is say it can scale however big you want, 99. And then you have people that go crazy hitting the F5 on their Tableau dashboards, and maybe they bog it down and you pay for it. Now, when you do scale horizontally, you do pay for 2 warehouses. So if you're on an extra small, when that other one's up, instead of paying 2 credits per hour, you're paying 4 credits per hour. But it handles concurrency really well, and it scales down. It also detects loads where it's saying, watch out. So we've talked a lot about vertical cluster scaling, vertical warehouse scaling, and horizontal. I want to pause before I jump into how to configure them and use cases, just to see what questions are there. So there's I'm not perfect. There's got to be at least one.
Well, I saw in the chat, Angelo, were you asking what ETL is, or are you just pointing out a link to it?
It was the term that came out of, where'd that come from? I said, well, let me look it up.
Okay.
So,
Oh,
and I also did a Google search on vertical scaling versus horizontal scaling, just to give me, personally, to give me more direction on what to look for after the presentation. So thank you. There actually is quite a bit.
excellent.
Okay.
Cool. Well, let's jump into how to scale, or how do we think about this. So if you put on your, let's say you love Snowflake and your boss is like, hey, go spin up some warehouses for me. Where do you start? The place that I like to start thinking about is how are grouping workloads based on similar query activity. So what I mean by that is, if you think about how do queries in reporting behave? So your Tableau, your Looker, your Power BIs of the world, how do those queries behave compared to, say, my data warehouse transformations? So like my DBTs, my Matillions of the world, because they're different use cases, right? And so since they have different behaviors, I like to separate them on different warehouses. So a good example of this is reporting. I might say it can get really wide because I never want my users to have to wait for another user's query to end, but I want to set a limit to it because I don't want somebody to be malicious and open up 100 Power BI dashboards all at the same time and press F5 constantly on them. So I want to set a limit to how wide or how many clusters can come up, as opposed to something like a data warehouse transformations, where I know exactly how long they're going to take. I know pretty well how long they're going to take, and I want them to shut off at certain times, and I want to kind of group them together. And so that's kind of the first thing that my head goes to, is start by grouping by use cases and behaviors. And then from there, I would start thinking about, well, how many concurrent queries will be running at one time. Perhaps you have a data science production load that runs once a week, and you know that it's a massive job, but there's like 1 or 2 of them. Or as opposed to something, going back to the reporting example, I have many unpredictable workloads. I have many unpredictable users. I might want to approach that differently. So after I've established what concurrency is going to look like, I like to go and say, well, how much are we willing to pay for speed? And I never say, how important is speed to you? Because the answer is always, it's important. So it's not, is speed important? It's how much are you willing to pay for speed? Because the reality is, there's not that much of a difference between 10 seconds and 20 seconds for a lot of data warehouse applications. There isn't, because we're mostly doing batch reporting. And so if you get somebody that says, no, I really want 10 seconds instead of 20, you kind of got to say, okay, but here's how much it's going to cost you. So, is it worth it? And there's cases when it is, right? You might have these, I point to the, well, I mean, if we talk about near real-time streaming, it might make sense to have a little bigger so that my streams don't step on top of each other, if that's what the use case demands. There's other cases where you say, you know, data warehouse transformations happen at 3 a.m, and it doesn't matter if they finish at 4 a.m. or 4:30 in, because nobody's looking at that until 7 a.m. And so that's where you kind of get to, I don't know, choose your own adventure, choose how much you're willing to pay for it. For me, when it comes to bait, just like gun to my head, spin this thing up right now. I usually start with an extra small with 4 clusters and use that as a baseline. The first time I rolled out Snowflake, I thought that a small would be wimpy, but I was surprised at how quick an extra small is. That it satisfies many of your use cases just out of the box. So it says extra small, but it's a lot better than the name kind of sounds. So as we look at some example configurations, these are some things that these are 3 that I spun up once upon a time that are kind of like this. Of when I do like your Tableau servers, your Power BIs, your lookers, this is what I like. 4 clusters minimum. You know, you start with 1, you can go up to 4, and you auto suspend after a period of time. I've done near real-time streamings where we say, nope, this thing always needs to be on because I'm always getting data coming through. So I never want that lag when I turn it on and off. So that's how I like to spin that one up. And then the compute data science, I like 1 cluster, large workload. These are not like, I don't intend this for data scientists to use as part of their dev work. This is more of, hey, it's, this is your weekly ML model that you want to run, or maybe you do this at night or every day at night. But whatever it is, I want to make sure I need this thing is really big and beefy and needs to go fast, because if it goes 24 hours, then it's stepping into it. It's not stepping on top of itself. So those are ways that I like to configure those. Something else to think about, and this is when you optimize these, or when you're scheduling, it makes sense to make sure that you have as many queries scheduled at the same time as possible. Now, you can't really do this with reporting because you can never predict your users. I've tried. It can't be done. If somebody figures that out, you're 10x better than I. But your reporting stuff, you can't really, your unpredictable users, you can't do this for. But when you're scheduling things like your data warehouse, your streams, your Tableau extracts, what you want to do is schedule them all at the same time. Because when that compute cluster turns on, when that virtual warehouse turns on, you're using it whether you have 1 query or 8 queries. And so to optimize for costs, you want as much on there as possible. One thing I've done in the past is open up the query log, and I have like a report that I would look at periodically that says, hey, I expect scheduled queries from between the 45 and the 15. Do I have anything that's running outside of that? And am I okay with that? And I found a lot where it was like, oh, no. Ooh, that shouldn't have been scheduled there. Or maybe I have a long running query here. And if I can find a way to shorten that query, I can take advantage of this. One way that I like to think about this is it's like if you were to rent a U-Haul and you were moving across town, you're moving from California to Lehigh, as is in vogue right now. Does it make sense to fill up that U-Haul 25% and do 4 trips? Or do you want to fill it up 100% and do 1 trip? So it's getting the most out of that U-Haul. So before we move on, I want to take a quick hit check, heat check, excuse me. I do see one question in the, let's see, I see two questions. So Stu, you're asking about Kafka, what's best for a Kafka Spark connection. I've never worked with Spark. I'm very unfamiliar with that space, but I have worked a fair amount with Kafka. Kafka, there's a built-in connector within Snowflake for Kafka. It's not as near real time as a lot of Kafka people like. The most that I've ever been able to really get it down to is like, I think we got down to like everything would process within 7 minutes, no more than 7 minutes from the time that the Kafka would land the data until it was ready to go. But it works really well for the most part. I'd give it like a B+, their built-in connector. You can also land your data directly into an S3 bucket and then ingest from there. You can schedule like a Snowflake task or something like that to just stream, or like whenever it notices something, just pull it in. So hopefully that I answered that question. If I didn't, holler and yell at me. Cody asks, do workload managers for this application? I'm thinking along the lines of Slurm type workload managers. Sorry, I do not quite understand the Snowflake platform. Well, I don't know what a Slurm type workload manager is, so I guess we're even, right? We're 1 for 1. Could you elaborate more of what that is, or if somebody else knows what that is?
Oh yeah, Slurm is usually used for like high performance computing, like workload managing. So like you send your, like it's a batch type. Like you send your script out to function on somebody else's clusters, like just on a schedule or wherever, like whenever the
Oh, gotcha.
system wants it to go.
Yeah, it's based on that description. It sounds really similar to that. You know, you'll write your query, you send it up to Snowflake, they process it for you at whatever speed you decide that you want to pay for. But they manage it all for you, so you only know that that's happening if you read deep in the docs.
Yeah, I think what I would add to that is that basically the Snowflake side of it is just taking whatever's thrown at it. You know, it's much more like a relational or something else where it's like, hey, we just sent you 1,000 queries. It's just going to do the 1,000 queries. There's no sort of, you know, processing, queuing, that sort of thing going on. I mean, it does it in the background, but it's not something you ever see. It just does it. Yeah. Okay. I had one question too about this, Jake, about you mentioned some where you kind of start out with small and you had some configurations up there, some common configurations that you do. You mentioned downgrading and upgrading those configurations is pretty easy. Do you see yourself doing that often on those clusters, or are the clusters kind of static and then you leave them there and then it's harder to reconfigure the clusters? Or do you find yourself configuring them often and changing them?
I do not configure them often.
Okay.
It's usually pretty infrequent. If you have to change them, it's really easy, right?
Okay.
There's no like update this query, you know, change syntax in this query or anything like that. It all happens, but usually it's a set it and forget it sort of thing.
It's not trying to rebuild like 2 terabytes worth of partitions or anything like that. Okay.
Nope.
Because they've separated it apart.
Exactly. It's literally just how fast do you want to scan the micro partitions and how many do you want running in parallel?
Got it. Okay. Sounds good.
So, so Stu, Databricks, I have like no background in Databricks at all. So I couldn't answer that question. Is there anybody else that has familiarity with Databricks and Snowflake?
Not using them together.
Cool. Well, so let's say you've got your clusters put together, you're ready to roll. you're, let's say, a week into it, a month into it, and you kind of have this question of, well, how am I doing? Are these actually performant? Are they not performant? I don't know. So Snowflake does a great job of, they provide a system view that contains a query log that you can just hit, and it has loads and loads of metadata about warehouse performance. My experience with the Snowflake UI and the built-in tools they give you is not very positive. It's not, I don't like it at all. So what I really, and maybe I'm just a visualization snob, the data nerd, whatever you want to say, but I like to hit the query log so that I can get exactly what I'm after. And what I'm looking at is, do I see queries that are queuing? And so they have a column, a metric that says, hey, this query couldn't execute on time. It waited 2 minutes because things were full. Okay, so if that's the case, I'll probably make that warehouse wider. I'll add more clusters. So then when that happens, it's ready to go. You can also look at long execution times. Maybe this is where you start to say, like, hey, my longest query is executing in 10 seconds or in 10 minutes. I'm okay for this use case if it's 20 minutes. I'm going to reduce the size. Or maybe I say, wow, my longest query is 45 minutes. I'm going to want to either refactor, or I'm going to want to increase that size because 45 minutes is way too long. And so it starts to give you those sort of insights. Some of the things I don't like about this view, though, is it is slow. It is painful to work with. It also keeps data for a year. You have to be an account admin to view it. I mean, you can mess with the permissions, but who wants to do that? So what I like to do, my coworkers say that I NSA it, that I'm the NSA with this, but I like to materialize it into a table. So now it runs really fast. I build reports on it, and I can do you can use this for query optimization. I'll use it to spy on my users. So for example, if I see the Tableau account running queries against a dev schema, no, don't do it. So I use it to enforce good practices. Or we have some wide tables that are not meant to join to anything that we put in the semantic layer. If I see people doing joins on those, it means either people aren't following the rules, that our data models and data sets are incomplete, right? We don't want people doing stuff like that. So I find this helpful, not just for query optimization and watching what you're doing, but also watching your users. One other fun use case. A lot of times people think they need stuff near real time. But there's one user that said, oh yeah, I look at this every day. And you look at the query log and it's once a week. And so you're like, well, if you're looking at this like once a week, do you really need it like every 5 minutes, this table updating? Because it's really expensive to do that. So, and I have a merge statement if you want it. We can post it somewhere or reach out to me or whatever. I'm happy to share. It's definitely not proprietary. It works on every Snowflake deployment in the world. So let's talk about some really expensive anti-patterns. So the first one is I want everything to go fast, so 5XL, and that's what I'm going to do. Really bad idea. Primarily because remember, there's diminishing returns. So a 6-minute query, that if a query runs, say, 6 minutes on an extra small, it's not going to run. You're not going to get that same performance on a 5XL. At a certain point, it levels off because there's just fixed cost. There's fixed costs associated with churning through those models. And so this next one, where I work at right now, it frustrates me because we had some consultants that came in, and this is how they stood it up. They said every user gets their own warehouse. Well, that's really inefficient because, well, I'm running my queries, and let's say I've got just whatever query running. The guy next to me is running his queries. We could be on the same warehouse, but instead we're paying for two U-Hauls. when we both could share one UL. And so this is where it violates that I want to stack my queries as much as possible principle. And so it's a common anti-pattern. The first Snowflake deployment I spun up because I was like, I want to protect everything from everybody. And it's a bad idea. What you want to do is group by use cases so that you're not overspending when things aren't going to be bumping into each other. And then this last one is one that people tend to they tend to struggle with a little bit, because sometimes they think, oh, well, I could have one small warehouse, or I could have 2 XL warehouses and it'll cost the same. And what's the difference? Well, the difference is how much you can keep those warehouses busy. And there's also the concurrency issue and the diminishing returns. So if when you look at things and you're saying, I want things to run, I want more throughput, it usually makes more sense to add more lanes rather than, add more concurrency, add more warehouses, add more lanes of traffic, if we take that analogy, than it does to double the speed limit. And so think of throughput on a highway. It's the same idea. If I-15 went from 70 miles an hour speed limit to 140 miles an hour, you're not going to get any more throughput. But if we build another 5 lanes, well, maybe, but we're more likely. I don't know if that'll solve the problem, but I'll give that a more likely. So if you find yourself saying, oh, okay, well, I have a Snowflake deployment. What's an easy way to kind of check through, check the boxes, see, is there any low-hanging fruit? How can I just bring my Snowflake costs down? The easiest one to do that I found is make sure you're on the correct Snowflake edition. So the Snowflake editions, as they go up in price, generally based on your feature set. So one of the differentiators is between business critical and I forget the one below it, is that it has better security on HIPAA and PCI. One company that I know of, I was working with them and realized, oh, wait a second, you have no HIPAA data, but you're on this more expensive one. If we change that, if you move down an edition, you're going to see an instant cost savings right out of the gate. So you can cut your costs by like 33%, just by making sure that you're on the right edition. Similar workloads running on the same warehouse is a good check box to say, yes, I am. Don't have too many and don't have too few. You don't want to run them all on the same cluster. You don't want to run 30 clusters. Right size warehouses for your use cases is a big one. Make sure that you're not paying for more power than you need. Make sure that you have the right number of going wide. And then the last one, I'm keeping my criticisms of the Snowflake UI to a minimum, but this one really annoys me too, because in the UI, as you're going and pushing buttons and you say, hey, I want this warehouse to turn off after X number of minutes. In the UI, the smallest option they give you is 5 minutes. But if you do it via command, you can set it to 1 minute. And that can start, that kind of adds up, right? Because maybe you've got a Tableau deployment and your people in Australia run something in the middle of the night and they're the only ones, and their query takes 1 minute to run. Well, if you have auto suspend set to 5 minutes, their one query, instead of paying for 1 minute for their query, you're now paying 5 minutes for their query. And so run that command that I have on screen, set it down to 60 seconds, 1 minute. The command will let you set it lower, but it won't actually be lower. Snowflake does a check once per minute to see, to check, are there still queries running? And so 60 seconds is the functional bottom of that, of what you can do. So we're at the end, and a shameless plug. Byte is hiring a mid to senior level data engineer. I also teach classes at Ensign College in Tableau and SQL. If you're looking for any entry level analytics people, let me know. And I also do consulting on the side. What questions do you have?
Thank you, Jake. Appreciate it. Yeah, definitely. If anybody's got any questions, just jump off and ask or put them in the channel. Give everybody a minute to ask.
So, Jake, right now my mind is kind of in the like the ORMs and stuff of Snowflake, like Django and or whatever ORM platforms. So on unit test, I know we probably don't we're not talking too much about unit testing, but I was thinking like how to we're trying to do data ingestion in Databricks through Snowflake. So I was wondering if like your recommendation on how to best go about doing that, either putting Snowflake in either setting it up remotely or having something local, like maybe I can treat it like SQL and just treat it like use a standard Postgres database locally. Maybe that would work. You understand the question? What I'm trying to do?
I don't. I don't understand the relationship between where Snowflake and Postgres would come in. Are you trying to
Yeah,
pump
we're
data
just like
from Postgres to Snowflake?
yeah, it's
okay.
oh no, I'm sorry. Well, we need to get the data, but instead of using SQL to query the data, maybe perhaps use an ORM so we can get it into an object model in code, and then that way we can then work with it directly. Maybe do a little bit more advanced enrichment or something calculations. So it just basically what I'm trying to ask you is like what's best for like a CI/CD pipeline in Snowflake.
Gotcha.
Yeah.
Honest, I don't necessarily know what's best. I know what I've used.
Mhm.
I've used Kafka and Fivetran in the past and it's not, I mean, it's not CDC,
Mhm.
but that's been my experience is getting that data in. I'm a big fan of Kafka. I'm not a big fan of Fivetran. It's okay, but I don't know. That's not a very helpful answer. The way that you stream, at least the way that I've streamed it in the past, is Snowflake has a concept called a file stage. And this is what all this is an S3 bucket or an Azure storage blob under the covers. And so you'll land your data in and you can land it in JSON Parquet, CSV if you hate yourself, whatever you want. And then you set up these merge statements to run periodically, and that'll keep it running. You'll never be able to get Snowflake down to like an instant or a sub-minute stream like with your it's just not something that it can handle. It's meant for more analytical workloads. It can do near real time, but it can't do like real time.
Mm-hmm. Okay.
So hopefully that answered. I know it wasn't a great answer, but it's the best I got.
Well, thank you, Jake. Appreciate that.
So they mentioned using the Bezium CDC from Operation DB to Analytic Data Store. We've used the Bezium connectors too as well. Not necessarily into Snowflake, but we used it for a connection as well.
Oh, nice.
There's pluses and minuses to Bezium. It's good and bad, like all connectors. Okay, well, if there's no other questions, for sure, I'm going to just go ahead